Okay, Ryan, let's read number 9, please.
If the limit as x approaches a of f of x equals L, where L is a real number, which of the following must be true?
So when something is approaching, does it have to have a closed circle on that approaching? If y'all remember, limit just means it's getting closer and closer to. So there's many of these you can draw, but I'm going to draw one that's going to probably satisfy none of these. So here's my A. Here I'm going to call this L, also called f of A. And let's say I have an open circle. And I have a graph that maybe looks like this. And let's look at each of the category. Can there be a slope at a hole?
No.
Nope, does not exist. Is it continuous at a hole?
No.
Nope. Is there a point at a hole?
No.
Nope. And since that one's no, can we automatically say D is also no? Because it doesn't exist? So we know it's got to be none of the above.
So that graph is basically just two lines going towards a hole. That's like what that.
I would think of more of one curved line with a hole. Okay?
No, it's a whole. It's just
How do you know the
It says which must be true though. Must be. So you have to think of all the categories that could make it not true. Okay? On number 10, Kenzie, let's read.
just say this one.
For x is greater than or equal to 0, the horizontal line y equals 2 is an asymptote for the graph of the function. Which of the following statements must be true?
So I want to look at just a definition of the asymptote. When we have y equals 2, it's got to be a horizontal asymptote, right? So I'm going to go ahead and draw one. And horizontal asymptote. And here's my horizontal asymptote at y equals 2. And this is actually going back to pre-cal even. When we had our horizontal asymptote, didn't the end behavior get closer and closer and closer to that number? Okay? Now, it really doesn't matter if you want to draw the graph from the top or the bottom, because in the end, we're going to reach the same limit. Let's say I have a graph that looks like this, that gets closer and closer to. And how was that phrased back in pre-cal? Looking at the choices.
approaching.
It is approaching 2. So limit as x approaches the infinity, it is approaching 2.